A straight line passes through the point 1, 5 and is perpendicular to the line 8y plus 4x minus 3 is equals to 0. Find the equation of the line. So we are being told of a straight line here that is passing through a point, let's say 1, 5. Then that same line is perpendicular to another line. So we can say that perpendicular line is passing in this manner so that the two are perpendicular. So that first straight line, we can let it be L1. Then this second line, we can let it be L2. So that we have two lines, one being perpendicular to the other. Then this second line, we've been given the equation 8y plus 4x minus 3 is equals to 0. So, to be able to find the equation of this other line, we need its gradient, then we can use an arbitrary point. So, we need to use this second equation to help us achieve that. So, the equation of a line is in the form y is equals to mx plus c. That is the standard form of an equation of a straight line. So, we want to write this equation in that particular format. So, 8y plus 4x minus 3 being equals to 0, we want to take these other values across the equal sign. So positive 4x, once it crosses, will be negative. Then negative 3, once it crosses, it will be positive. So we'll have 8y being equals to negative 4x, then plus 3. Then we need to also make the coefficient of 8 to be 1. So we divide through by 8. Divide through by 8. We will obtain y, because this 8 will cancel, is equals to negative 4 divided by 8 is negative a half x, then plus 3 all over 8. So having the equation in this standard form, from that standard form, m represents the gradient, the coefficient of x that is. So here, the coefficient of x, which is negative a half, represents the gradient of this line we are calling L2. So let that be m2 to represent the gradient of the second line, which is negative a half. So if two lines are perpendicular, then we also know that m1 multiplied by m2, they should be able to give us negative 1. But for this case, we do not have m1, but we have m2 as negative a half. Negative a half, which is equals to negative 1. So what is this m1? So we will do this, we will multiply both sides by 2, so that we want to remove that. So m1 times negative 1 would be equals to negative 2, would be equals to negative 2. So we also want to remove this negative so that we be able to get what m1 is. So we divide through by negative 1, divide through by negative 1. So we'll have our m1 being equals to positive 2. So now we have, for this case, we have our m1 being 2, then one of the points is 1, 5. So our gradient m1 is 2, then one of the points is 1, 5. So we'll use another arbitrary point, let it be x, y. So that now with the 2 points and the gradient, we can be able to find the equation. So we'll say let this first point be x1, y1, let the second point be x2, y2. Then we will use the formula that to obtain gradient. You take y2 minus y1 all over x2 minus x1. Our gradient is 2 is equals to our y2, which is y, minus our y1, which is 5, all over our x2, which is x, subtract our x1, which is 1. At this point, you can quickly cross multiply and say 1 times 1 minus 1 times y minus 5 is equals to 2 times x minus 1. Then 1 times y is y, 1 times negative 5 is negative 5, is equals to 2 times x is 2x, 2 times negative 1 is minus 2. Then to simplify, we'll collect like terms, add 5 to both sides to remove this negative 5 here, or simply take negative 5 across the equal sign. So y will be equals to 2x, then minus 2 plus 5. Then y is equals to 2x, then plus 3. And that is the equation of the line.